So Brian, so we can get started?
Yeah, I think we can go ahead and
Okay.
got how many, 19 people in? Yeah, I think we go ahead and start it. Go ahead.
Okay.
Go for it.
Okay. Yeah. We're right on the time. So hello everyone. Welcome to our SCONE working group interim meeting. So this is the first interim meeting of the forming this SCONE working group in Dublin, and hope everybody are doing well of the Dublin meeting. So we see a lot of active many discussion. Special thanks Lucas, Ted, and Marcus, and many other. Hope this will be good input for today's discussion. And note will apply as usual. So please make yourself familiar with Noteware, and this is all about the rules, how you make a contribution to the IETF, how the RPR disclosure can be applied with IETF policy. And we also have a code of conduct. Please be aware of your rights and obligation. And so in W meeting, we review several proposals, and this proposal can be broken down into two bigger categories. The first is a long MySQL proposal. The second is a MySQL proposal. For a long MySQL proposal, can be further broken down into chain protocol and SCONE protocol and others. To better formulate this discussion and harmonize all these proposals, make it a better shape, better scoped. So two things agree in the W meeting. First is set up two work stream. The first work stream will focus on semantic content of the protocol. The second work stream will focus on protocol framing and syntax. The second thing we agree in the W meeting is schedule several interim meetings before the IETF 122 Bangkok meeting. And this is the first interim meeting we have now, and we will further schedule two other interim meeting in the next month and in the months after that. And for this interim meeting, we do have some hiccup, for the polling tools, and hope we can fix that later. And so here's the goal for today's interim meeting, and the important goal is really review the status of two work stream. For the first protocol work stream, we want to focus on consolidate the chain protocol and SCONE protocols and identify a set of concrete requirements, most focused on security and deployability requirements. And as for the semantic work stream, and we want to converge on a way to express the throughput guidance semantically and explore what the client really needs and what the network can provide. Further, we'll establish the experimentation and pre-interoperable test. And the goal is to make a MySQL and non-MySQL approach to better interoperable. And the expected outcome will be the preliminary hackathon project in the Bangkok, and we really want to focus on this hackathon project planning in a subsequent interim meeting. And so this is the agenda for today's discussion, and we received three agenda topics. The first is the consolidation of the SCONE and the chain protocols. And we have Marcus will lead this discussion. The time length is 40 minutes. After that, we have second topic is a SCONE throughput advice object. This topic will be led by the MED. The time length is 20 minutes. And later we have a SCONE experimentation, and we have Abhishek, who helped to lead this discussion. Without further ado, and maybe we can move to the next, the first topic.
Actually, Ted asks a good question in the chat. Chairs, do we have a note taker? Ted, are you raising a problem, or are you volunteering? And silence means raising a problem, not volunteering. Do we have anyone who would like to help us take notes? Okay, Ted can be a backup, right? Because for the interim, we do not have the auto The auto stuff. I don't know. I usually pick on Tommy. Hi, Tommy. How's it going? No, it's kind of early in the morning. Martin, thank you very much. Martin Duke will be note taker. Ted Hardy can help out. I'll open it up and keep an eye on it as well.
Okay, great. Thanks. So let's move to the first topic, Marcus.
Right. Will you drive the slides, or should I?
Do you want me to drive the slide, or you want to share by yourself? I can drive
slides. Maybe I can do that.
Okay.
Do I need to do something to? Am I sharing the slides?
Yeah, I didn't receive your request. Maybe I share for you, or
is this deck is being shared? Oh no, that's you. I saw it try to start. Anyway, okay, go.
Okay, there we go. So I guess you're driving it. That's totally fine. There are not many slides. There are not super much information in the slides, because I really hope that this is going to be more of a discussion rather than a presentation. But yeah, I'm going to talk about train and SCONE, and kind of what's similar and some differences in design and philosophy and points of discussion, to see if we can kind of, I mean, this is the first interim. I'm not sure we can kind of agree on everything, but I think it's good to start discussing these topics and hopefully move towards converging on something that can look like a protocol framing that we can agree on. So yeah, next slide, please. So yeah, a little bit of background then. We have these two individual proposals. They are quite similar in many ways, but there are some philosophical distinctions, I think. One being perhaps that, like, we can see we are moving somewhere between, like, how much can we limit what a signal contains but still be useful, versus how flexible can we make a signal, and how flexible does the signal need to be. And I think what we need to do here in these discussions is to kind of find some where on this spectrum we need to be, and where we can kind of agree where that there is a useful place to be. So there's here in this presentation, there's a list of discussion points. It's definitely not exhaustive. This is just some points that I have raised that I think are some of the most important distinctions that I've seen, that I hope we can talk about. And let's make this an open discussion. It's not for me to just present, but rather just facilitate the discussion. And we've had some discussions starting on the mailing list already, which I think has been great. And hopefully the outcome of this would be that we can kind of aim for some converged proposal that kind of makes everyone happy. Next slide, please. Let's start with the first topic, maybe. And yeah, just to say, I will not go through details of these proposals. These proposals were presented at the last meeting. The drafts are there. They're relatively short in their presentation. So I'm kind of jumping right into the discussion points. I hope that's okay. So anyway, one of the first and most discussed points that we've recently started discussing on the mailing list is the actual format of how we encode the signal. Noting that we have not yet kind of come to any conclusion or made any progress on the semantics word track, there's still like an important distinction between these proposals on how we decide to encode the signal. So in train, there is the train proposal is to use a minimal amount of bits to be able to encode the throughput guidance. It basically uses 6 bits in the packet header that then can map to a table that gives you 63 kind of rate limits that you can communicate. These will be predefined and kind of standardized and stored in some registry. And I mean, this is obviously giving you a minimal packet overhead. You only have this. You have these 6 bits available in the quick long header that the proposed wire format is based on. And of course, it kind of restricts the expressiveness or the semantics, like how much you actually can express with this protocol, and that's restricted by design. Again, with this philosophy in mind that we should design the minimal thing that is actually useful. So that's kind of and the rationale here is, by the way, my interpretation of the rationale of the decision. If any of the authors of the draft is actually present and you think that I'm misrepresenting the rationale, I will be posting rationales on many of these slides. Please let me know. But basically, the idea, as I interpret this, is like, let's not design more signal than what is actually needed. So let's do the minimal thing, make sure that the minimal thing is useful. SCONE, on the other hand, takes a slightly different approach. There is an explicit rate signal field that can contain any value that fits the bounds of that field. So in that particular proposal, there's a 32-bit integer that represents a bit rate, and there's another integer that represents an averaging window, and basically that gives you a little bit more freedom as a network element to express what kind of policy you want to express. So and the rationale there is like, basically we cannot predict what values are going to be useful, so therefore kind of give the freedom to the network elements to decide this. And with this said, maybe we don't have a good resolution to this particular question until we actually make some more progress in the semantics workstream. But I would like to hear what people think about this. I mean, I can say what my current view is, and I expressed in the email, is that I'm a little bit worried about this small bit field that we kind of encode values that we think are useful, but then might not actually represent what is useful in the real world, and therefore adding more flexibility might be a good way forward. But I would be very happy to take and hear comments on this.
So it sounds like we have Jonathan
Sure.
in queue.
Yeah, I'm not an author on Train, but I think there was, as I understood it, there was one more design constraint for Train that was important, that it thought it was important, and we need to figure out whether it is, which is that Train, the spots the information is put is in a fixed location in the packet, which is supposedly much easier for routers to do it. I think we're going to need to understand from people who might be implementing this whether that is a significantly easier than, having to find a variable offset based on the connection ID length and whatnot, rather than just being able to plop it in a fixed spot in the packet. So I think we need to understand how much of that is, how important that constraint is, because I think that's the main motivation for this thing for Train, as I understood it.
Yeah, that's a very good point. Can I reply, or should I go into queue, or how do we handle this discussion? Okay, yeah. So I think I agree, and I think that's one of the important trade-offs. So as someone who would implement this in a network element, this is one of the attractive features with Train, that you don't have to do a variable offset. On the other hand, this signal is not as frequently sent and modified as something like ECN. This would rather be something that is way less frequent, and I think it can be a worthwhile trade-off to do a variable offset. It's not that much more expensive, but this is also something that we might need to experiment with.
I was going to say, I don't think, when I've talked about this internally, I don't think we've come to a strict conclusion on whether we need more bits than Train is currently offering. It certainly makes some things more complicated, but at the moment, for the existing use case that we, definitely know we want, it seems like it probably actually does have enough signal. Either way, I mean, one concern that we've come up with is, the more information you expose, and that poses some amount of risk as a working group. And I think probably for both of these, we will want to have strong suggestions on how often you send them, as in do not send them too often, right? Because the amount of information you can expose is, the number of bits you give people to play with times the frequency you send it, approximately. So that's just so on the other hand, that means that if we were exposing more bits, we could probably actively mitigate that by kind of providing appropriate advice on sending it less often. And it seems like, we could say, well, ECN is a few bits, so, As long as we're leaking, say, like half as much information as ECN, maybe that's fine. I don't know. I mean, the working group would have to decide like what bar is relevant. But anyway, I guess that seems like a mitigatable problem if that. So as an individual, at least, I wouldn't want that to be the reason we don't go with the more flexible approach. But other things like it's easy to use as an operator because it's at a fixed location. I'll buy that. I mean, that does seem easy. So.
Next, Shihang.
If you're speaking, we can't hear you.
Hello, can you hear me?
Yep.
Yes.
Okay. Yeah. Another difference between these two proposals regarding the signal field is that the train puts the signal field in the plain text in the quick header, and the SCONE put it in the quick payload, so it's encrypted, right? Is my understanding correct?
So it's not necessarily encrypted. In the SCONE proposal mentioned that you could use crypto with kind of the quick initials using publicly known keys and so on. That means that it's not really encrypted in any meaningful sense. Anybody who wanted to observe this would know and would know how to unencrypt it. So I think you can safely assume that both proposals send the information in clear text. There is no proposal that proposes confidentiality. If you need confidentiality, I think you have to go for the mask type of solution.
Okay, so SCONE does not use some kind of quick TLS related encryption to protect this field. It's a well-known public key.
Yeah. So the SCONE proposal is a little bit of a stub, but then what is discussed there is that you could use crypto similar to the quick initial cryptography, which is not it does not give you proper privacy or proper obfuscation. It obfuscates to the path, but anybody who knows what to do could decrypt these packets because it would be used publicly known material to derive keys. Yeah. And I think none of these solutions are proposing to have a fully confidential model. No.
Okay.
The next, Abhishek.
Yeah. I think it's too early to be able to get to a decision on this. I think that is what being said in the chat thread also. We need to maybe answer this question with data, collect information on, just from personal experience working with CSPs, we have seen a variety of ways data rates are measured and specified. Sometimes just an average rate, sometimes average plus burst rate, sometimes a statistical like a curve, a CDF curve of rates that one must conform to. So there's a large variety of things out there, which I think the working group does not have enough data yet to make that decision. So my recommendation would be maybe one option could be that if it helps working group, maybe some of us can put together, at least to the best of our knowledge, an internet graph which sort of puts out these various ways in which the current throttlers and policers sort of work worldwide, and then maybe we can make that decision.
Can you volunteer to sort of try and pull that together by our next interim, whenever that is?
If it's January, the interim, if it's in January, Brian, I won't be able to do it, but
yeah, like we'll figure out the scheduling, like in terms of, so like, yeah, let me put it this way, a future interim. I
can volunteer to sort of take lead on that.
Okay.
To present it in the future. interim before Bangkok, but not
Thank
necessarily
you.
January.
People who have data about this, please go talk to Abhishek.
So I just wanted to kind of pick up on something that Ian said and to confirm something with the group. Ian was talking about how often we need to send the signal. I think in the train protocol, what turns out to be the case is that every so often the server creates the scribble space, and in a different interval, maybe every time the scribble space is available, maybe not, the network element that is expressing the constraint writes into it, right? And I think if that's how we're thinking about this, we actually have kind of a need to think about the fact that the server won't have any feedback necessarily from the network element of change. So it needs to do this at a period that's defined in terms of like RTT or time or something that's observable to them without creating the need for a second throughput, a second channel up from the network element to the service. So I think given that, my instincts are to kind of keep the signal low. But I do think we want to be careful not to overthink this much, because at this point, as far as I understand it, the only thing we ever want to really express at the application consumption layer is, and thank you to Alan for the friendly amendment on the list, is reduce your quality of experience just a tad, please. And so what we're asking the application to do is to reduce the quality of experience in order to not consume so many network resources. And because it's always a downward thing, you really could do it by saying, okay, we're going to just keep ratcheting you down until you fit into the current constraint. But that would be no better than the way it works now with TCP, right? So what we're trying to do is to improve on that by sending what are in essence pieces of the feedback in a feedback loop faster than TCP would. So I think, and unless we come up with a reason that we need a signal that says, hey, go back up, then I think we actually don't have a huge problem in setting the feedback loop in terms of downward pressure. Because ultimately, again, like we're talking about, in many of these cases, we're talking about AVR video or similar, where there just aren't an infinite number of steps. So I think we probably can model this in terms of the fact that we have an endpoint that may know a great deal, but is trying to elicit a fairly simple behavior set, and then think about what the range is we need to be able to elicit. And the ultimate end of the range is they don't pass any packets because they've exhausted their buffers or whatever. But that isn't something you need to signal because the failure tells you that. So it's actually not that problematic, I think. But Gory knows a great deal more, and I'm sure he's answered me several times in the queue while I was talking. So I'm gonna stop talking and go read the chat while somebody else gets in queue.
I think that was a really good comment. Thanks. We actually have a later slide where we do talk about the frequency of the signal as well. So I think that's great. We're starting to touch upon that. One point on that you raised, I think there probably could be cases where there's value to signal actually go back up, because at least some of the discussions around use cases for this is, it's network policies around shaping, and these policies can be somewhat dynamic based on the awareness of the access network conditions. So there are there could, for instance, be policies that depend on like which tracking area a user is in or something like that, because that might be a much more loaded part of the network and things like that. And then you might actually want to signal different policies when you move in and out of these areas and so on. But I guess that's, yeah, we need to collect more requirements on this. So on this slide, unless we have more people, I think it was a very useful discussion, and I think I agree that we cannot resolve this now. I think we need to collect more requirements on many dimensions. And I think it's an excellent proposal from Abhishek as well to to collect this information on various traffic policers and shapers. And yeah, I would be very happy to help out with this. And I also think that we need to do more work on the semantics workstream, because depending on if we're okay with only signaling a bit rate, or if it's something in addition to the bit rate, that also makes a big difference on like how much space we need and so on. Okay, then if no more comments on this slide, we can maybe we can jump to the next one. This one is again it's looking at the current state of these documents. It's a packetization pretty much, and this one is kind of related to the next one as well. But here an important distinction between train as it's specified and SCONE as it's specified right now is that in train the train packets themselves are inserted by quick endpoints prior to quick version 1 or version 2 or whatever quick version you decide to use in your end-to-end packets in UDP datagrams. So in a single UDP datagram, you will have the train packet followed by the end-to-end quick packet. And this is a very important reason for doing this. One of the most important reasons, there might be many, but the rationale is that when you bind the train and quick packets, you actually reduce the risk of path spoofing attacks, because the receiver of a train packet can validate the inner quick packet that follows the train packet and only kind of take the train packet into consideration if the original quick packet is actually valid, which then makes it more difficult to do, kind of replaying of these kinds of packets or injecting them from the side. SCONE, on the other hand, as is defined right now, the network element, once it knows that it can talk SCONE to an endpoint, it basically generates new packets in new UDP datagrams. They are separate from the end-to-end quick packets, but they then share the 5 tuple fields that they kind of copy from the end-to-end, and also the fields like the quick connection IDs and so on. And the rationale for that was that these packets can reach their intended target. You don't need to tie them into the same datagrams. It will, as quick packets, it will work as well. Of course, then this has the drawback that you don't get this type of protection. And it would be good to hear if people have any opinions on these two aspects.
Okay, I guess I should start. In general, I prefer not creating more packets and the appending approach. It doesn't seem like anything about SCONE or train makes it so you couldn't do the other approach for either one. So it seems kind of like how we do this is sort of orthogonal, but I tend to prefer putting it along with an existing packet, and that also means there's some amount of fate sharing, because I would like, I think, to do loss detection on whether I believe a given train, SCONE, whatever packet arrived. And the easiest way probably for me to do that is to use my standard quick loss detection machinery and assume that if the packet that was appended after the train or SCONE packet was received, that probably, hopefully, the train or SCONE packet was received. And certainly if that second packet was not received, I think it's reasonable to infer that probably the train or SCONE packet was not received. So may or may not be important to do loss detection or like have some idea whether your signal made it through the network. But I think there are use cases for which it would be nice at least to know that it made it all the way to the other end.
Yeah, that's a very good point. Of course, it's loss detection from the point of view of one of the endpoints, but that endpoint doesn't necessarily know whether a network element actually inserted something into that signal packet.
Yes.
But you're right.
You could be detecting the loss of a useless piece of information. Although, I mean, if you lost the rest of the packet, you probably want to do something anyway. I mean, so.
Yeah.
So I had 2 points on that. One, I tend to kind of agree about the coupling of the packets. So for people that have been for original fans of this stuff, you'll remember that the precursors to some of these proposals that predated SCONE originally did have the extra signal coupled with the packets. So I think it's technically feasible for example, to have a variant of SCONE that did that, since we already kind of fleshed out those a little bit. So there are some nice properties. One thing I will say, though, is that this rationale about spoofing, I don't think is very compelling, mostly because in both Train and SCONE, there's not really any way to verify that the insertion of the train signal into a packet was done by a server endpoint. So having access to the path in both cases, you have to be able to modify and forward packets in order to send either signal. And that's not really a compelling difference, in my opinion, between Train and SCONE, because there's no authentication of the signal in either case. So that's something that I think there are practical considerations. I'm not sure that there's really a security or spoofing sort of rationale behind coupling them.
That is a good point, and I think that also something we can discuss further. And if no more on this, I can go to the next slide, because it follows very much on the packetization, and it comes down to some of the points that actually Ted started discussing, and that's the signaling frequency or the timeliness of the signal, or whatever you want to call it. So here there are also two fundamental differences that have various properties or various consequences. So with Train, as we know by now, Train packets are inserted by the quick endpoints at their discretion. So if you want signals in the downlink direction, so you're a server and you think that your client wants to have rate signals, you as a server are kind of at liberty to determine when and how, at what points and how frequent you insert these packets, so that the signals can be the signal fields can be modified and then reach the client, and vice versa. So that means that whenever there's a change in policy, this policy can be signaled at whatever point when a train packet is observed by the network element. Of course, the rationale behind this is that you want to give endpoint control of the signaling frequency for various reasons discussed here as well, like that actually gives you some control of how much signal we can send over the path and so on. But it's also kind of a natural consequence of this packetization approach, that it's if you tie the packets together, maybe it's more straightforward that is actually inserted by the endpoint. You know what to do. You know how to limit your payload sizes and so on. So you can actually give space for this additional header and so on. In SCONE, then the packets are sent kind of at the discretion of the network element. So the network element determines whenever there is something useful to send, a new signal will be generated. And of course, the rationale behind this is that the network element is the one that is aware of when a new signal is, like, new information is available to transmit. And there are some consequences on this aspect. Is first of all is like, okay, if you have somewhat dynamic policies, they are still relatively infrequent, and extremely infrequent if you compare to something like ECN. So you might have a subscription-based policy that you want to send at the start of a flow, and then you might have a policy that you want to send if some condition in the network changes. And that might be, many seconds or even minutes from when you sent the first signal. But when that event actually happens, you might want to send this information in a timely manner. To ensure that timeliness with Train, that means that the server needs to decide upon some frequency of sending Train packets which is acceptable, so that you actually have the possibility to react to dynamic changes in the network, which means that most probably there will be a lot of useless information in these packets. So you need to generate these packets. The network has nothing new to put into the signal, and then it passes through. But the network might still need to actually look at and process these packets, because if you don't put a signal in, that might be a signal in itself. So there could be a lot of work involved in that. At least that's how train is specified right now. On the other hand, we know, as was discussed, that SCONE, that allows the network element to send packets at any point in time for any reason. Well, that gives you a pretty strong signaling channel. So you might then claim that you can send a lot of bits over the wire. So there's a little bit of a dilemma here on how to reconcile the kind of some need for timely delivery of signal, but maybe not over like having to send a very high frequency of signal. So two models here, and will be, again, interesting to hear what people think about it. Sanjay?
Hi, thanks. Thanks, Marcus. First of all, apologies. I'm in the vehicle, so there might be some noise, and I apologize for that. So I think I just wanted to say one point, that the change in policy is probably better if that comes from the network side, because network has awareness of if there's a change in your radio access type. If you switch over from LTE to 5G, then that might cause an update to the signal, or other situations where you drop down to maybe LTE, or it might be a factor of your data plan that might cause the signal. So I think if the consideration is given to that, send the signal only when is needed, and that if that part is reliant on coming in from the network, then you have that advantage of only knowing when something needs to be said. So I think in that way, it sounds like SCONE is sort of in that direction. But either way, either of the approach that can follow the lead on the network would probably address the issue.
Yeah, and I think, for all fairness, both solutions can do that. It will still be the network that is aware of some change. The issue is when, when can the network signal that there has been a change in policy, right? And with train, that requires, because in train you modify packets that are sent by an endpoint. So that means if you want a very timely update of the policy, that requires that there's a relatively high frequency of train packets being sent. How high that frequency is.
Sorry, I think I spoke over you.
No, it's fine.
Yeah, I think the frequency is important. That the network element is processing the place in the network that is doing this is doing a lot more other work, which is to ensure that it's communicating with the radio access network. So we definitely want to minimize the traffic, the burden on the network element, in order to determine, for example, in the case of train, if more packets that it has to inspect to say nothing changed, that in itself is causing the network element to spend some cycles that it shouldn't be spent on.
Any more comments on this?
One quick comment, and I apologize, I need to reread the draft. But if the network element is sending packets any time they want, that means they need to know whether the flow has negotiated, like SCONE or whatever the mechanism is, right? And so that means that the network elements are doing more, not deep packet, but more handshake inspection, not less, which sort of makes me sad.
Yeah. So in what the current proposal in SCONE is that basically the endpoints in a given 5-tuple, the endpoint generates a SCONE packet so if a client wants to receive signals, it sends a SCONE packet towards the server, and if the network element determines that, sees that, it can determine that for this 5 tuple I can send. So it's slightly similar. It's just like you have to observe a packet on that path that indicates that this is SCONE capable, and once you know that, you can then inject packets or whatever you want to call it. Whereas the other model is more like, okay, I see this packet and I can modify it. So yeah, there's a slight difference.
Yeah, the list is not tied to the handshake, so I mean, I'm not terribly sad about it, but okay, thanks.
Nick?
Yeah, I wanted to bring up a topic that I was going on the chat. I'm not convinced that for SCONE, the network will be able to inject packets that have the right connection ID and connection ID length in long headers. That assumes they can infer that from traffic that's going around. The first problem is inferring connection ID length, right? If there's any kind of migration, all of a sudden there's packets flowing, short header packets. You have no idea what the connection ID is. So yes, you can see the tuple, you can see some bytes. You don't know if it's 8, 12, 20 bytes. So I don't know how you can have a system where you expect the network to reliably inject packets that are going to get routed properly.
In that, the way that SCONE does it right now is that the endpoint generates, like I said, the endpoint generates a kind of initial SCONE packet on that tuple that the network element sees, and it's the values, and that's a long header packet, and it's the values from that packet that it should be using in the packets that is sent. So that means that there might actually, the packets that are sent by the network element in that case might actually have different connection IDs than what is actually used on short header packets that going on in that end-to-end transaction, but it would use whatever was sent in that SCONE packet. And that might have a bunch of issues, but that's at least how you would solve this how you would solve this issue with knowing what lengths of connection IDs to
So
put.
the endpoint would be expected to resend this every time there's a tuple change?
I think you would need to do that if there's tuple change, yes. Yeah.
Okay, thank
you. Okay. Lots of useful discussion here as well. Then if no more comments on this slide, then we can probably go to the next slide. And we actually did reach this slide. I was unsure if we would make it here, but we did. So I think yeah, like I said initially, I don't think we are able to resolve these questions, but it would be good to discuss what was the right way forward. Is the right way forward to just adopt one of these proposals and start working on it, or should we actually try to work out some starting ground with like trying to reconcile some of these issues before we adopt something as a working group document? And I guess this is a question both to the group and to the chairs, maybe. So
yeah. So actually, I threw myself into the queue as the chair to more or less start that conversation that you just did. So I'm going to drop out and then come back in at the end.
yeah, we have a queue here, so please.
Switch on.
Oh, dropped.
No, Martin.
Yeah, I think of all these things. To me, the signal format is almost orthogonal. Like we could just have like a blob, and we could make that blob arbitrarily long just by sort of tacking things on. Whereas the other properties of this seem to be very inherent to the protocol, for lack of a better word. And I personally like the I mean, for the most part, I like the properties of train. I think the one thing that is really missing is this signal frequency issue, and I would hope that can be massaged by looking at the payload and maybe having a sort of a time to live for the advice, and possibly some sender side heuristics to say, like, boy, like my quality is really kind of gotten really bad. Maybe I should ask again. And I think those two things together would probably mitigate some of these problems, and then give us the sort of the fate sharing and authentication properties of train. I think another way of saying, I think train is probably a better basis to start from, but some of the elements of SCONE that you highlighted would be relevant there.
Thanks.
So, hi, I'm back, chair hat. Oh no, wait, go ahead, Ted.
So somebody said that they, Hamshar said they reminded him of Spud and Plus. Please don't bring that up. But I do want to point out something else, and that's in WebRTC. We went through a long period of like baking off various different proposals that were finally merged, and what you ended up at the end of the day with was something that didn't end up looking like any of the original proposals at all. Because once they'd been merged, then the working group got to work, and it changed them in a whole bunch of different ways, such that the eventual JSEP, it's very difficult to trace its lineage back to the origin proposals. So my core advice here is, if you think the set of people who are the current authors can work together, or some subset of them that's willing to continue, then picking either one and doing the best of both is fine by me. I tend to agree with Martin. I prefer train for much the same reason he does, and I see the same issue he does. But if we can agree that we're going to try and converge to get the optimal set of properties, I don't think the end is going to look much like either of what we've got right now. So it's not nearly as important to me to pick as to begin the work on whatever we pick.
That's a good suggestion.
All right, so wisdom from the chair, I guess. No wisdom at all. I think so. What I saw in this discussion was a bunch of really good questions. A bunch of, I think we're getting very close to sort of what the sort of decision points would be between a protocol, between like sort of like the various shapes of the protocols that we already have. I think we're going to have a little bit more discussion about like potentially other data points, but like from a shape of the protocol standpoint, I would say personally, I have kind of the same biases that Ted does in terms of like pick one and get started. There is a little bit of a question that I would have as the chair of like, hey, can we just nominate a subset of, or a set of the authors from both of the proposals? Do y'all think that you could come together, decide who's going to edit the combined proposal, and then we can talk about that next time? Because I think I'd actually like to work from a concrete proposal that has, you know, that incorporates the input from this discussion, as opposed to like try to take a hum of, should we start with SCONE or should we start with train? Because I think that Ted is right. We're going to end up with something that looks very different no matter what. And what's most important is getting, you know, a GitHub repository with text in it. So Marcus, you're here doing this presentation. Are you willing to be one of the people who would start that new draft?
I would be very happy to do that.
Cool. Matt, would you also be one of the people who would be willing to start that new draft?
Yeah, I mean, I would say that, though we should note that none of the train authors are here. So I don't think we can really speak for what they're willing to do or compromise on.
No, we obviously would have to take this proposal to the list. Like, I mean, there will be a follow-up discussion about this in its own thread after this interim. And also a note to chairs to try and pick a time that sucks less for Australia next time. Like, you know, the pain is global. And actually note to chairs to pick a time that sucks less for China as well. So I think we have, at least as the chair, the way forward, and then we'll take this discussion to the list.
Very good.
Cool. Thank you, Marcus, very much. Next up, Gene, who do we have? I think we have Med next, correct? All right, you're driving the slides. Med, take it away.
Yeah, so thank you, Brent, thank you, Shane. So we'll be presenting, I would say, the a proposal for having a blob for the throughput advice. I will let my co-authors, Dan, Thierry, I don't know if he's connected, and Sri and Louis to further comment if there's any point that you want to make in. Do you have the control, Shane, on this? Yeah, so the main goals, I would say, when we started to have this work is to have something which is really reusable blob, independent of how the signaling channel we will be picking for this in SCONE. This will be a protocol or an API. No, I would say no assumptions on the coding itself, whether the signal is, I would say, reactive, proactive, and so on. So make as much as, I would say, abstract on the signal itself. The second goal we wanted to also to achieve and also to start is to have a common understanding what currently available on the network side and what these networks are ready to, I would say, to share with the host and with the applications. I would say the goal behind this is that if you want something that will be really implementable, deployable, it should be something that readily available at the network side. This will ease the integration, and then I would say we can start for something which is there. The third objective is, yes, there may be something which is really available at the network, what the network can be sharing, but is this something which is useful for the application themselves and how the applications and the host will be making use of, I would say, that signal. Next slide, please. Yeah, so just I would say to have a reference on what we are talking about is I would say this is really very simplified. And so what we have there a network provider. We don't want to get, I would say, into the internals of how the network provider, I would say, network is structured. We don't make any assumptions on, I would say, the topologies there. We have multiple servers that are available on the network itself. The servers may be providing multiple applications, not necessarily from the same provider as obviously. And then from the network provider itself, there are two types of, I would say, customers we are serving. The first one is customers with, I would say, handset and I would say hosts that are directly connected to the network, and that host provide multiple application clients that are provided that host. And there is another flavor which are all that we have, for example, in the broadband customers. We have you have a C there, and you have a bunch of hosts that are, I would say, connected behind that C to the network. The network that doesn't have, I would say, any visibility on the internal structure of the local network. It doesn't know, I would say, how the resource partition are done in the local network, or whether there are existing, I would say, network partition at the network itself. And all what we know is that we want to send something from the network in the direction to the host and also to the CE, and how that signal can be, I would say, useful for all these types of hosts. Next slide, please. So the approach I would say we followed so far is that we use the CDDL for I would say for us to structuring the I would say the blob itself, and that I would say that format can be mapped to any encoding specific to the signaling channel, and then we can these protocols we define that map in there. And the second one is that we leverage on the existing technologies for configuring, I would say, policies in the provider network. There are a bunch of them with, I would say, common parameters are, I would say, present in all of the flavors of the policies that can be provided at the network side. And some of this, I would say, this information, they are already shared with the customers for some from specific services, but those all, we don't need all that amount of information to be shared for the SCONE case. Next slide, please. So this is just to give you, I would say, the amount of the richness of the information that is available today. So there's a lot of information that can be available. It can be on per site, per service, and so on. So, and the exercise we need to do is what I would say subset of this information will be useful for us in SCONE. Next slide, please. So we structured, I would say, the structure of the throughput advice is that it can include multiple instances. Typically, one instance for, I would say, per direction, because you can have the direction from the network to the host, and the other one from the host to the network itself to have, I would say, the policing in place. We don't make an assumption whether all the instances have to fly in the same message or to be sent in different signaling messages. This is really a deployment specific, and this will be dependent on the solution that will be in place. And also we assume that the same format will be used to advertise the first time, I would say, information from the network to the host, but also to refresh this information when that information is stale or there is a new value that are, I would say, need to be communicated to the customers. So, and for even, I would say, then for each throughput instance, there is the same structure that is repeated then that we can show in the next slide, please. The first one is really the, I would say, the meat of what we are doing here is the rate limit itself. And we define two groups. The first one is in which you have, I would say, the mandatory one about the CR and the CBS, and then you can have an extra rate in when you, for example, to accommodate some of excess traffic. And the other another one in which we have, I would say, the peak rate, and all of those are really optional. And it depends on the policers that are really enforced in a given network. Both of those are really optional so far in the blob, but so, and we will discuss in the future whether we need to keep all this in I would say optional parameters, or we just stick in a first version of the blob only on the mandatory one to be supported. Next slide, please. Then I would say once we have, I would say, the rate there that are announced, let's say, from the networks to the host themselves. There's the question is that the advices, they have specific scopes. For example, in the previous slides, I have shown all these types of I would say hosts that are connected to the network. You have the hosts that are directly connected to the network, and they are also the CPs. So the question is, should we define, I would say, so far we define three types of scopes. The first one is the subscribers tab. That means that the network doesn't know exactly the granularity of the host. So all what it knows is that this is just a per subscriber policy. So, and it's for a given subscriber, there will be multiple hosts there, or we know that there is I would say a directly connected host, and this policy will be for that specific host. And there is another, I would say, value that we at least we considered in the current version of the specification, the flow scope of the rate limit. There are actually a lot of challenges for that one, which is, I would say, some of them was already discussed on the mailing list. This is not something which is currently supported by typical access routers, and also at the network side, we don't know how there is no, I would say, no clue how you can partition the resources to bind them to a given flow. So the two ones that are really realistic and that are, I would say, reflect the current deployments, maybe the ones that are really bound to a host or to a subscriber. And the question for the group is there really need to, I would say, to have this value of having something that will be specific to the flow, and if so, how this will be implemented, and so on. So this is really an open question we have for the working group. I don't know if we want to take the question for this, at least the discussion on this specific point right now, or to leave it at till the end of the presentation.
Right. I'd say go to the end because I don't see anybody jumping into the queue, and yeah, let's take to just broader questions at the end.
Okay, next slide, please, Chi. So the next one we have, I would say the address can also for a given direction. So you have the direction from the network to the host, and the other one from the host to the network. And in the throughput advice blob, we have the explicit, I would say, information about all of those. The default one will be the one from the network to the host, because this is what is currently of interest. And there's a specific value that we wanted also to define, just to ensure, I would say, the compact encoding when there is the same value that are applicable for both the direction from the hosted network and also from the network to the host. Next slide, please. This is something I would say we spent some cycles between the authors. We need to, I would say, to cover this in the blob itself, is whether we have, I would say, dedicated rate limiters for whether the traffic is really for reliable or unreliable. So far, at least what we decided is to keep it there, with one suggestion that this, for example, a typical use of the reliable and unreliable is to use the QB and the NQB, but the signal and the identification of the flows will be up to the application. If the application, for example, decides to mark using a public information to the network that this is, for example, for QB or NQB, so that's the this will be, I would say, a trigger to, I would say, to use it to enforce the rate limit itself. Other than that, if it is not, I would say, explicitly provided, that means that the network won't care whether this is for reliable or unreliable, and the same rate limit will be provided and enforced for these flows. That's also one of the, I would say, points that we would like to have, I would say, more feedback from the working group, and also whether this is something which we need to cover in the blob itself. Next slide, please. This one is currently on the traffic categories. Is that if you send, for example, a given, I would say, a rate limit that you send to the host, and we say that this is something which is applied, for example, for a host or for a subscriber, and if you want to have something which is really granular for some specific applications or from specific type of traffic, we need a means to convey that to the in the rate limit so far. And so the only value we have currently defined in the blob is that for all the traffic, because we need to have the discussion whether we will define traffic categories, and whether it makes sense to define traffic categories or just reuse what is currently, for example, defined in 3GPP or in other forms that like GSMS and so on. So what at least the current approach we adopted in the draft is that we say that we only define for all the traffic, and we define a new registry for if in the future the working group all wants to define new traffic categories, whatever that means. So we need to characterize them, and all of those can be registered, and the usage will be specified in the future. Next slide, please. So this is just to illustrate, I would say, how the blob can look like if you use, for example, JSON notation. So this is for, I would say, a throughput advice. It includes both direction with different informations that are specific to each rate limit instance. Next slide, please. This one is to illustrate the use of when you have same one single, I would say, instance that covers both directions with the minimal information that needs to be conveyed from the I would say to characterize a given rate limit. Next slide. I think we can just move on move to the next one. Yeah, so those, I would say, some open questions that we would like also to discuss. There was a question from Jason and the mailing list also on whether we need to have the class ID and the PHP. So that's really that's open, and also whether we need to link the information that can be available at the bearer level. For example, if you are sending, I would say, this information over, I would say, a cellular network, there are already some information that is provided at the bearer level on the QCA and so on, and whether we need to, I would say, to link them and to bind them there. So those are really open questions, and more feedback from the working group is really wanted. So with that, we are open to have the discussion on all of this. And I let my co-authors, if they want to jump in. Yes, Marcus?
Yeah, hi. We're taking general questions now, or yeah. Okay, yeah. So thanks for sharing this. I think it's very interesting. I see this. I think this is a very useful thing to have presented, because I think this is kind of on the spectrum of what we need to communicate. I think this is kind of this is kind of a maximalistic approach. This is really more or less providing an application with the configuration of the policer in the network, all kinds of things like burst rates and committed information rates, and potentially what if it applies to a subscriber or whatnot. And that might be very, very useful. I think what would be very important now is to understand what of this information is actually useful for an application, say like an adaptive video application, for instance. Does it need to know things like burst sizes and so on? And I think this is a good starting point to look at, because here we really have like the whole suite of things you can communicate about a police implementation, more or less. Yeah, just want to make that comment.
Dory, go ahead.
Sure. Okay. Yeah, I liked the kind of looking at all the space. And when it comes to the PHP information, the packet that's carrying this has a DSCP. Is that not the scope of the response? Are you expected to send a map for all the DSCPs or PHP groups or something, Mohammed?
No, actually, I'm not expecting any. I would say for this. This is a comment from Jason on the mailing list. I don't know if he's connected. He can clarify. I would say the request he has behind this.
Yeah, we can follow up on the list. That's fine.
I realize I have one more comment, if that's okay, or question. So you were talking about whether you need like traffic classes or tying this to. I think one traffic class that we have been thinking of in SCONE is like something that is capable of receiving train or SCONE packets. And the question is, do we need more granular traffic categories than that? I think that's also a question.
Yeah, I think that's a fair Marcus. Yeah, we need to obviously discuss what granularity we really need in order to, I would say, to enforce, I would say, the rate limit. Because this will depend also on the channels that will, I would say, convey the information. If it is even if it is with the same flow itself, does not mean that flow will be consuming, I would say, that rate limit itself. Because if we are sure that we are stamping, I would say, the rate limit with that flow, that means that there is some identification at the network side to make sure that this is binding the rate limit to the appropriate flow, which is another story, another complexity on the deployment. And I don't want it to open that door so far. But yes, that's a fair comment that we need to discuss as well, Marcus.
Okay, I think we have cleared the queue on that one directly on time. Thanks for keeping it on time so we can get to our last bit. Yeah, I heard at least one conversation to continue on the list, and we will discuss it there and talk about what comes out of that the next time we meet. Thanks very much, Med. And Abhishek.
Yeah, thank you. So I volunteered last minute to lead this discussion on what kind of activities, SCONE experimentation activities could be useful for the working group. Again, this will require a lot of groups feedback, and our intent here, if you go to the next slide, was to first start with a high-level categorization on the kinds of experimental themes that we may want to pursue as part of the working group. So we have chosen two broad themes. One, the second theme is very familiar to the IETF way of working, which is running code. And that is focused more on working out all the clarity and correctness of the spec that this group will generate, as well as the implementation complexity, the interop, the debugging tools that we'll need, and all that. The first one is more focused towards bringing relevant technical data to facilitate scale deployment of the output of this working group, which is the SCONE protocol specification. The way we see these two different themes laddering up to the two distinct deliverables that this working group has is that the theme one has more applicable, is directly applicable to the applicability and manageability specification document that this working group has to produce. And the second one will contribute directly towards improving the protocol specification document that this working group has to produce. And that was the key reason why we thought to sort of categorize it this way. Now, I did go through this earlier, but what kind of technical questions would these experiments clarify? So we already talked about the various configuration options, like of the shapers and the policers that are currently in the networks. How can so quantifying benefits of quality of experience with a SCONE assisted application self-limitation versus the existing way of network throttlers. Could be some experiments could provide data on that. One of the key questions, one of the additional questions that I have heard in the discussions is what kind of additional CPU memory power and incremental deployment complexities does SCONE add on the network side? So again, these are all ideas on is it worth to spend some time on quantifying that to facilitate easier deployment of SCONE, or facilitate scale deployments of SCONE, where some of these questions can be addressed by data and experiments instead of opinions. And yeah, so that's how at least I thought we'll structure the discussion on these two different themes. The technical questions on the second theme, as I said earlier, is the spec written correctly and clearly, and are there any loopholes in the spec itself that can only be nailed down by running code and doing hackathons? And that is where that all falls under the second theme. Next slide, please. Some questions when we started thinking about it, some high-level questions. Will it be possible to have a realistic operator network configuration? Do we need it, or is a lightweight approximation possible? Now, the challenge with lightweight approximation is that the data that you generate should be valid enough so that you can extrapolate meaningful conclusions for the network operators, where one side of the SCONE network element will sit there. So we need to think about those questions. Is it necessary to have a realistic server client endpoints? So if can we work with toy video server client endpoints? Again, will this be represented enough to extrapolate conclusions for content providers? One of the examples of this in the working group discussions, mailing list discussions, was around prefetching and how the SCONE signaling could be used for not just quality choosing the right ABR quality, but how often to prefetch and all that. So we need to think about, do we need to how should we experiment? Or do we need realistic server client endpoints? By realistic, I mean, like, do we need an actual, like, for example, in the IETF 119 experimentation that Meta and Ericsson did to produce some of the QE data, we were actually using the real Facebook server and the client apps to do that. But is that even necessary? Maybe for wider experimentation of the working group, maybe do we want to use some open source toy client service endpoints? Again, in this is the first time we are talking about experimentation, so you would find more questions than answers. But wanted to leave the group with these questions so that we can maybe generate some interest on people jumping in on these two themes to have some ideas on that we can work on in future meetings. I'll let Wesley present the last slide, where we have just outlined a few different options that we could come up with, but this is not an exhaustive list by any means. Go ahead, Wesley.
Yes. Go to the next chart. Yeah, so this was just a brainstorming list we started yesterday, actually. So it could use some other inputs, but we thought to meet the goals that Abhishek was just reviewing, we would need several different things that people might contribute, for instance, as hackathon activities. But in total, it's a more complex set of things than a simple client-server protocol, because we also have the thing in the middle of the network that has to do the signaling, and we have the applications that have to deal with the signals that they would be getting through the quick stacks. So there's multiple pieces that need to be contributed together. First thing we thought of was that the ability to just measure the types of impacts within the network on a throttler, shaper, policer type of device to quantify the savings in CPU, memory power, things like that. Some kind of testbed setup that can do that is necessary. As well, since there's multiple things that need to be orchestrated in order to do these kinds of tests, scripts and software that enable that would be pretty useful. For instance, just repeating the mask demonstration from Brisbane would be something that other people might want to do themselves. And we also thought of the quick interop runner and a system like that or extension of that in order to test SCONE support between different pieces of implementation. We also thought about an operator core network emulation that could be doing the policing and the signaling, for instance, using an NS3 or a TC-based approach. The SCONE ecosystem itself consists of a number of pieces that usually will be provided by different people. So the quick stack, the in-network signaling, the application itself, or some of the libraries I see Lucas is mentioning in the chat that would need to receive and act on the signals. And then just tools like Wireshark being able to decode SCONE information in packets and help debug it. And then, of course, an interop network with some of the pieces like live and available to test against would also be a valuable thing someone might contribute. So it's just started a brainstorming list. We wanted to have a discussion and see what people were thinking might want to collaborate on in the working group. That's all I've got.
Yeah, that's the last slide. We can leave this up for discussion. And
the queue is open. Go, Marcus.
Thanks. This is a really great start on this topic. You're covering a lot of things. This will probably very, very much incremental. Just being able to test anything initially will be great. But I think one aspect that I think you talked about it, but maybe didn't put it explicitly, that maybe you should put on your first slide is, I think we need to do tests on what amount of signal or what kind of signal is actually useful for an application. There was a lot of talk about QE or about memory consumption and so on, but to get to that point, I think we need to also kind of figure out, like, basically the signal semantics, like how and I think that might be something we need to do in this interrupt testing as well, and that might be something that you want to spell out on the on the first slide there. Or
yep, no, very good point. I think it falls under theme 1 for sure, and also because it's not a protocol handshake interrupt issue. It's more of, okay, how do you
No. So exactly. So it's a little bit more on that. The other point I also want to make, I think it's like bullet number 1 on this slide is great in theory. Would love to do that. The problem is that a lot of these implementations of policers and shapers in the wild are highly proprietary, might be highly tied to very specific platforms. Like, are you doing the policing on some kind of router, or are you doing it in a packet core user plane function or in something else, and what kind of hardware platform are you using, etc., etc. So like we have to be very much aware of, like, it's a great aspiration, but what we actually can kind of achieve and say about like how much resource usage these different kinds of traffic shapers, policers, etc. actually, I mean, what the properties are is I mean, we will not be able to do something. We can do some approximation of it that, based on standard mechanisms, I think. And then, of course, as vendor, and we might be able to share some data. I don't know, but I think individual vendors and operators would probably need to share that data if you want something that is very reliable on that sense. So just but I think it's a good aspiration. So, yeah.
Next, Lucas.
Lucas, you might be on mute if you're talking.
If you're talking, we can't hear you.
I know. Can you hear me now?
Yes, we can.
Yes, that's a local user issue. Sorry. Yeah, I just want to reinforce Brian's +1. Like, thank you very much for bringing this and presenting the work. I agree. There's a lot more questions than answers right now, I think, which is why I really wanted to start the mailing list discussion. As somebody who hasn't been involved in any of this, like, how can I describe SCONE to people who aren't protocol experts or anything, but understand product? And like, I can say, look, there's these folks over here who know what they're doing. They've defined some good measure of what QoE is for some kind of video streaming app. And what they're saying is, if we did something along these lines, the details will change. But if we did something, we can improve QoE by something, right? Like, this is why we should be thinking about how we build this product, or how we gear up our networks to exchange this data, how we make sure our load balancers are going to support all of these weird, wacky things we might want to do. My concern is, without any of that, we just show some graphs going up, and they're like, "Cool, that's fine." Like, I don't understand what this means. And we can go back over the slides and that stuff. So I just wanted to figure out, like, what is the experiment? Like, define that. Like, I would do with any kind of undergrad student. Like, tell me what you think the experiment is, and if it's constrained or caveated, that's perfectly fine. But at the moment, it was just a bit opaque to me. All this other stuff about making it more extensible and reproducible, I would absolutely love, but I don't want that to put people off who already have their own private test beds and their own apps and stuff from carrying on and presenting data back to us, as long as it's easy for us to understand. So thank you.
Next, Sanjay.
So Abhishek, thank you, and Wesley. I think this is really good of raising these types of questions, because I can see a lot of value um, in in experimentation here, particularly if something like SCONE were to be deployed in the network, then performance of those network elements that would be impacted by adding the SCONE capability is important. So I think, to the extent, if it is possible, something where uh, this operator network can be available for some of this experimentation would be really good, because deployment at the end of the day will really be driven by what is the performance impact within the network element as you add this capability. So I think that might answer those questions if some of that is done in real field trials, etc. So thank you.
Yep, and yeah, please feel free to, as we said, that this is just a brainstorming session. We try to just, which is why you see more questions here. But this is more for the working group to start thinking about these things. And if you have any ideas, please feel free to contribute. Tell us if something's wrong. Tell us if something we are incomplete, and you can do that over mailing list. And hopefully we'll be a lot more organized on the experimentation next time we meet in interim meeting. And hopefully it'll ladder up to something useful that we can do experiment-wise in Bangkok.
Cool. Thank you very much. I'll say what I said in the chat. Thanks a lot for pulling this together, especially sort of like on the notice that it was pulled together. This, I think, was super useful. The original version of this agenda basically had the chairs rambling on and having a discussion of where we want to go from here. We have like 3 minutes for that, so I think a lot of that has to go to the list anyway. I do want to ask while you're still on and sending video, your opinion of, like, I had like a very sort of like strong personal desire to get to the point where we can do probably not an interop, but a workable hackathon in Bangkok, right? Like, use the fact that we're all going to be there, that there is a hackathon before. I think from this and the discussion that comes out of this, I'm gonna drive to go ahead and get that table anyway. I'm not sure what's going to come out of it. How are you feeling about that? How are you feeling about like taking this discussion and like driving it together with a working group to the point where we can at least, I mean, we don't have to have like fully running stacks or anything, because we're just talking about merging the protocols, et cetera, but like something that we could do useful here. What would be like the first thing that we could put together for Bangkok? I'm putting you on the spot with like 60 seconds left, so maybe that's a thing we should take to the list too.
Yeah,
yeah, good.
I can't tell you that what would be the successful thing, but I think given given that we have questions and people aligned on the questions, and we have a motivated group here, we should be able to do something. I won't be able to pinpoint what exactly. I think that is more meaningless discussion.
I think that'll emerge out of the thread that comes out of this discussion. So as far as scheduling the next interims, we will take that discussion to the list as well. We will be using something other than Zcal. I don't think anyone was happy with how that particular calendaring thing worked. Me as the person running it was also not super happy with it. We'll find an alternate for that. Noticing with regret that we do not have any of the train authors in the room for this meeting, we will see what we can do about shifting the line of pain across the globe somewhere sort of like the time zone line to maybe change the set of people for whom this is easy and hard next time. We will follow up on that. Not sure whether we'll get one or two before Bangkok, because Bangkok, of course, is the beginning of March, but we'll take that to the list as well. Are there any other things in the remaining 10 seconds that anyone would like to discuss in person? Ian.
I wanted to point out that Renji Teng wrote a short draft about acknowledging or conforming to the signals being sent. And this is in the context of, it's nice to know that you sent the signal. It's nice to know what the peer is going to do with it. In particular, it has been observed that situations where instead of using the policer when sending the signal can allow the network operator to not use the policer at all or set it to like a much, much higher value, that has improved QE quite a bit more than when the network operator just tells us, hey, there's a policer here and here's how fast it is. So call that out.
Cool. Those of you who have not, I think I saw that go by to the list.
I'll put it on chat.
Yeah, cool. If you have not had a look at that, please do. All right. Thanks all very much. We will see you at the next interim, whenever that is. Have a great day.
Thank you.